Hey everybody, Mr. Payne here for September 3rd, Wednesday homework practice problems. I'm going to help you with number 1 and maybe take a look at a couple of the other ones as well. So it says in Suri's coin purse, she has 6 dimes and 4 quarters. Martha has 5 dimes and 3 quarters. Suri thinks that the ratio of dimes to quarters is the same because they each have 2 more dimes than quarters. Is this the same ratio? Well, let's see. So we're going to make a table here. And what I'll do is have this be dimes and quarters. And Suri is 6 dimes to 4 quarters. And meanwhile, Martha is 5 dimes to 3. Okay, so basically, the way to do this, there's a couple ways you could do this. You could ask yourself, is there a way you could go from 6 to 5 or 4 to 3? That's a little bit more difficult, okay? So what you're going to want to do here is change one of the 2 coins to the same number. And what I mean is if you have 6 dimes here and 4 quarters for Suri, if you change the dimes to 30 by multiplying by 5 and change the quarters by multiplying by 5 to 20, that's the same ratio. 6 to 4 is the same as 30 to 20. Okay? So what you would want to do here is take the 5 for Martha and change that to 30 as well. And how do we do that? Well, we'd have to multiply the 5 by 6 to get 30. Now, what would we have to do to the 3? Same thing, multiply it by 6. And if we get 20, we have identical ratios for the 2 girls, but we don't. We get 18, okay? So, basically, when the dimes are 30 for Suri, the quarters are 20. When the dimes are 30 for Martha, the quarters are 18. So that means the original ratios of 6 to 4 and 5 to 3 are not equivalent, not equal, okay? So you may be wondering, why did you choose, Mr. Payne, why did you choose to change this to 30? Well, because I have 6 dimes for Suri and 5 for Martha, so I changed it to a common multiple. That way I know if I change both dimes to 30, I can figure out whether or not the ratios are equivalent because the quarters would also have to be the same numbers, okay? It's harder to tell when you have 6 to 4 and 5 to 3. Okay, let me take a look at another one of these here. Number 2, in a trivia game, Levi answered 8 questions correctly out of 8 turns in the game. He then answered the next 3 questions correctly. He reasoned that because he added 3 to both the total questions and his correct responses, that the ratio of correct answers to total questions remained the same. Is he correct? Well, we'll have correct responses. Let's make a table. We'll do, let's do responses, or correct responses, and questions. And it says here that he answered 8 correctly out of 10 terms in the game. So 8 correct out of 10 questions. Now, he reasoned that because he added 3 to both the total questions, he got the next 3 questions correctly. Because he added 3 to the total questions and his correct responses, that the ratio of correct responses to total questions remained the same. Well, what did we talk about adding? And I'm sorry, I'm not in the picture here. What did we talk about adding? Can we do adding and subtracting when we're doing ratios? We want to concentrate on multiplication and division. So, also, does this make sense? 8 out of 10 is 80%. So, if you get 3 out of 3, that's another section of questions where you get everything right. Isn't your percentage going to get higher than 80%? Right? It's not going to stay the same if you get everything right. It's just like free throws. Basketball, if you make 8 out of your first 10, that's 80%. And then if you hit your next 3 out of 3, you're going to go up higher than 80%. So think about that. Is he correct? Does his percentage or does his ratio stay the same? Okay? So basically what you're going to want to do, you're going to want to set up tables. I mean, that's what I like to do. I like to set up tables for these. Just like the fruit punch and the small fruit basket, they give you some of the tables. Like this is some of the stuff that you could use to help you answer the questions. All right, so one batch of fruit punch has the ingredients shown. If the punch bowl holds 27 cups, how many cups of orange juice will she need to keep the ratio in the full punch bowl the same? Okay, so think about the total that this creates. All right, how many total cups of juice are there here compared to the 27? All right, think about that. We did whole and part today in class. Same thing here with the fruit basket, right? Total pieces. Well, first of all, how many total pieces are in this basket? And what about the large basket? Well, what do you know? And then on number 10, the next question. Oops, sorry. On number 10, it asks you to find the mistake. So the ratio of quarts of white paint to red paint is 3 to 4. A student says that to maintain the same ratio, he will need to add 7 quarts of white paint if he has 8 quarts of red paint, because there was originally 1 more quart of red paint than white paint. So is that true or not? Is that true? Again, you want to make a table. White to red is 3 to 4. Is 7 to 8 the same? Well, ask yourself, what would you do to the 4 to get 8? Think about that, see if it makes sense, okay? All right, good luck. I'll see you on Thursday.